In this video, we are going to make sure that the string of the bow is interactive so that we can pull it and push it so that we can later on add an arrow and we can let it go by letting go of the string. Okay, let's get going. In our project, in the hierarchy of our bow, I have included for you the midpoint parent. This is just a point placed in the middle of the bow string that we have created using our line renderer. To visualize it, we are going to select this midpoint parent, right click on this, create 3D object, a cube. It is a bit too big of a cube, so let's select in the inspector the transform, let's select the scale, let's scale it uniformly, and let's set it to be something like 0.05. This will create a small cube in the middle of our bow string. Now, to make this interactive, we have already on this a box collider. So what we can do is add to it, as you might have guessed, 𝗃𝗲𝗃𝗀𝗃. And again, I have mentioned that we have placed this collider inside the bow evil 𝗃𝗃𝗃𝗃𝗃 because now when we have added to this cube, let's rename it to midpoint grab object. We have added to this midpoint grab object a box collider. And if we haven't placed in the 𝗃𝗃𝗃𝗃𝗃 of the bow in the array the collider that belongs to it, the cube collider would also trigger grabbing the bow and not the string. But now, as we have added this midpoint grab object and it has its own grab interactable, it will use the collider placed on it or its children, so child colliders, to trigger the behavior of grabbing this cube alone. Now we need to tweak here the rigid body that was added. We don't want this to fall down, we want only to be able to interact with it, pull it and push it using our hand. That's why we want to set the rigid body is kinematic to be true. Now to avoid any issues with this, we need to select the 𝗃𝗃𝗃𝗃 interactable and we need to select throw on detach at the middle bottom of this and we need to uncheck it because we cannot throw a kinematic rigid body. If this was a dynamic rigid body, when we would let go of it, it would fall down onto the floor. This would happen because of this 𝗃𝗃𝗃𝗃 interactable. One more thing that we can do is select our box collider. Since we do not want it to be a collider, let's set it to be isTrigger to be true. With all those settings prepared, we can just press play. Okay, let me try grabbing the bow. And we should have this cube in the middle of our string. If we try grabbing it, you will see that now it follows our hand. Now it stays in place, but in addition to that, it also follows together with the bow. So if we make sure that it always stays in the middle of the string, we can use the movement of this cube to move the string together with it and to implement our bow movement and interaction mechanic. Okay, so let's stop our project. Now, if you haven't unchecked the throw on detach in the 𝗃𝗃𝗃𝗃 interactable, you would surely see in the console some warnings about it not being throwable because the rigid body is non-kinematic. So right now, what we need to do to make sure that the string moves together with our cube is to create a new script. So let's right click in the scripts folder in the assets in the projects tab, create a new C# script. Let's call it bow controller. Okay, we can actually call it bow string controller. Okay, let's open this script up. Great. Let me paste the fields first. So we are going to need to have a private bow string reference, bow string renderer. This is our line renderer. As you might recall, it has one method that allows us to pass a third point to our line renderer to be rendered. Next, we are going to also need a private 𝗃𝗃𝗃𝗃𝗃 interactable reference called interactable. Let's right click on this 𝗃𝗃𝗃𝗃𝗃 interactable, quick actions, and we are going to be using Unity Engine XR interactions toolkit. Okay, so now it should the red squiggly line should be gone, and we are going to also have a reference to a SRS field private transform midpoint grab object. This is our cube that we are grabbing using our other hand. And we are going to have a reference to our private transform interactor. This will be the hand position, so the interactor, so our basically hand in VR, and we are going to use it to move our string. Now, obviously, we could use the position of the midpoint grab object, but I want to show you how we can grab the reference to the hand object to use it in a script. Let me paste some methods that we are going to be using. So we are going to have a private void awake, where we are going to grab the interactable reference by setting it to be midpoint grab object. So this is our cube that we are dragging using our other hand, get component XR grab interactable. And this is it for the awake. And we need to have this interactable because in private void start, we are going to use interactable.selectEntered, which is an event that is sent by this interactable object when a hand or any other interactor that we have in our game, so in our case is the hand, when we press our grip trigger, we're going to grab this object, it will send this event select entered. And we are going to add listener here because this is a Unity event. We're going to create prepare bowstring method. You can right click on this quick action and at the bottom you have generate method. Now the next thing is the interactable select exited. So this is when we let go of our grip trigger, when we let go of the box that we are dragging using our other hand, we're going to add listener to it, reset bowstring, right click on this, quick action, and we are going to find at the bottom generate method. We are going to prepare our bowstring by making it follow our hand when we are grabbing the cube, and when we let go of the cube, we want to reset it, we want to set it back to be straight string on our bow. We want to reset the position of our line renderer. So starting with the reset bowstring method that was generated for us, I'm going to paste here 3 lines. Interactor, we want to set the interactor to be null. Next, we want to reset the midpoint grab object local position equals vector3.0. This is because we are using the local position, the local coordinate space, so the vector3.0 is just the origin position where the string is straight. And we are going to call bowstring renderer, so this is our bowstring reference, create string null, so we want to recreate the straight string. On the other hand, in the prepare bowstring, we are going to use those select entered event args because we are going to have here interactor equals args 0, so this is the name of this argument, interactor object, so this is the reference to our hand dot transform. This is how we can grab the reference to our hand object in a script. Now, last thing that I want to do is I want to make sure that our string is created according to the movement of our midpoint grab object when we have grabbed it. So we are going to add an update method here, so private void update, and we are going to simply check if the interactor is not null. In this case, we are going to always call the bowstring renderer, we are going to call create string, and we are going to pass the midpoint grab object dot transform dot position. So we are going to basically create a point in the middle of our string that is at the position of our grabbed cube. Okay, now before we save the script, make sure that you go up because I forgot to add to this bowstring a serialized field attribute, so we are not going to be able to assign it. So we need to have a serialized field private bowstring renderer. We need to assign it through the inspector as well as the midpoint grab object transform reference. Okay, sorry about that. Let's save our script and let's go back to Unity. In our project, we want to select the bow evil and we want to minimize all the other components and drag here our bowstring controller onto this object. Now we're going to be able to assign the references to the bowstring renderer, which is simply our bowstring visualization object, and we need to have a midpoint grab object reference. So let's select our midpoint grab object from the hierarchy, and this should be it. Now we should be able to press play and test our setup. Great! Now if everything went fine, we should be able to grab our bow, and we should be able to grab the cube, and the string should follow our position of the cube. Now we can grab it and move it anywhere we want, which is, in my opinion, is not how the bow should work. Now obviously you may want to leave it as is, but what I want to do is I want to constrain this movement, that despite the fact that my hand is here, I want the bowstring only to go in this axis forward, and I should be able to pull it at some point. There should be a limit where I cannot pull it anymore. And this way we are going to be easily able to read the strength by checking against the limit of how much we have pulled the string. So basically what we are going to do that, and if I let go of this, now the string resets. So we already have this mechanic where we can let go of the arrow and it will fly forward. Now we also need to add an arrow, but for now, let's make sure that we can constrain the movement of the string, since that's what I want to have in my bow mechanic. So let's stop the project. So to start working on the constraint system, we're going to go to our midpoint parent, and we are going to right click, create a new 3D object, a new cube. Again, we are going to change the transform and the scale to be 0.005. And for now, what we can do, actually, I think it was 0.05. Okay. And now what we can do is create a different material to visualize how our constraint will work compared to the position where our hand is. So let's go to our assets, materials. We are going to right click here, create a new material. This will be a temporary material. I just want to set here the color in the inspector. I'm going to set it to, for example, red, and I'm going to assign this to the cube that I have just created. I'm going to rename this cube to be a midpoint visual object. Okay, and we are going to use it in our script, and we need to just go back to our assets scripts, and we are going to reopen our bowstring controller script. Great. Here we are going to find the line where we have the transform midpoint grab object. We are going to add here 2 more references. This will be the reference to our midpoint visual object that we have created and to the midpoint parent object. Now the midpoint visual object is what I'm going to use to show you how the constraint system will work, and the midpoint parent object is needed because we are working in the local space. So we are going to use this transform to calculate to convert the world position to the local position to use it in the movement of our visual object based on what we have later on in our script. Now, if we want to have any kind of a limit, we need to add it here as well. So I'm going to create a serialized field, private float, bowstring stretch limit, and this will be set to 0.3f. I find this value to work best, but you're going to be able to modify it through the component in the inspector. Now let's slide it down because we need to find the reset bowstring method. Here we have resetted the midpoint grab object. We want to do the same with the midpoint visual object dot local position equals vector3.0. So we again reset this as well. Now the biggest change will be in our update method. We're going to have a couple more method calls. First of all, we need to get the position of our midpoint in the local space. So we're going to have a vector3 midpoint local space equals midpoint parent inverse transform point. We're going to convert the midpoint grab object dot position. Now, of course, we could also take the local position, I think, of the midpoint grab object, but for the sake of understanding what we are doing, we want to convert the hand position to the local space of the midpoint parent. Now when we have this, if we take a look in the scene view, if I move this midpoint visual object in using this forward direction, we can see in the inspector that in the position field of the z value, it is negative. So what it means that when we are pulling our string, we are setting the negative value on the x-axis of this midpoint visual object and of course on the midpoint grab object. Now I'm talking about the local space of the bow of the midpoint parent. And this is important. Let me reset it to be 0, because what we can do is we can use this information by calculating flow midpoint local z absolute, so abs, equals mathf.abs midpoint local space dot z. So this is the z value, but absolute value of it, and it gives us the idea if we have moved this position of the string or not and how much. And we can compare this to the value of the limit that we have created, 0.3f. This is our limit. So we can now check this absolute position of the z value against the limit to detect if we have reached it or not. Okay, so based on this midpoint local space and the midpoint local z abs, we're going to have 3 methods. First one will handle string pushed back to start. So what happens if we push the string towards the bow? I want the string to just stop in the position where it is straight and not go any further. We're going to pass here the midpoint local space. So this is this vector3. Let's right click on this method, quick action, and generate this method. The next method will handle string pulled back to limit. So what happens if we pull the string back until we have reached the limit? Obviously, I don't want to go any further than the limit. So here I need to pass the midpoint local 𝗃𝗲𝗃𝗀𝗃 as well as the midpoint local space position. Let's right click on this method, quick action, and generate this method. Last method is handle pulling string. So the general case, what happens when we are pulling in between the 0 point and the limit. So this will again take the midpoint local 𝗃𝗲𝗃𝗀𝗃 and the midpoint local space vector3 position. Right click on this, quick action, and generate this method. Now this might not be the most effective way to call those three methods, but I tried to make the code as simple as possible. And at the end, we are going to call our bowstring renderer create string passing the midpoint visual object dot position. As you might recall, this converts internally the world position to the local position. That's why I'm not passing here the local position, but the position in the world space. Okay, so first of all, we have this handle pulling string. So this is the default method that happens when we are in between the 0 and the limit of the string. Let me paste the code here. It is pretty simple. First, we need to check if middle point local space z, which I have told you that we are using basically it to measure how far we are from the limit and from the 0 position. If this is less than 0, because we have the negative values, and if the absolute value of the z is less than the limit, we are in the space in between the 0 and the limit. So what we want to call is midpoint visual object dot local position will be equal to new vector3 0 0 midpoint local space dot z. So basically we don't want to move it on the x, on the y, but on the z, passing it the vector3 position, the z value of this position. Now the second method is handle string pulled back to limit. So this only happens when we have reached the limit. So let me paste the code here as well. So again, it will be a simple if check. If midpoint local space dot z is less than 0, and if midpoint local z absolute value is greater or equal to the bowstring stretch limit. So this happens when we have pulled our cube above the limit that we have accepted. In this case, we just want to set the midpoint visual object dot local position equals new vector3 passing as the z value minus bowstring stretch limit since z is negative. Okay, and the last thing that we need to handle is what happens if we have pushed the string towards the bow. So here we are going to check if midpoint local space z is greater or equal to 0. So if this is positive value or 0, now we need to just set midpoint visual object dot local position dot equals vector3 dot 0. Since we are working in the local space, vector3 dot 0 is the origin position where the string of the bow is straight. Okay, that is it. Again, make sure that you check out the GitHub repository if you are not sure if you have typed this correctly. Let's save the script. Let's go back to Unity. Okay, great. So in the Unity project, let's select the bow evil, and we are going to select our bowstring controller script. Now it requires us to pass it the midpoint visual object. So let's drag it from our hierarchy, and we need to have the midpoint parent. So again, let's drag it from our hierarchy. Everything else should be set. So if everything went well, let's now press play. Okay, so now let's grab the bow, and we can see the red cube, but we are going to grab the gray cube. And as you can see, the string is only pulled so far. When it reaches the limit, it simply stops. If we push it towards the bow, you can see that it stops when the string is straight, and that is it. And when we get the hand on the sides, you can see that it only pushes or pulls the string on the z-axis, on the local z-axis, until it reaches the limit. Now, it might not look great that our hand is so far away. We can of course add something to break the connection between the cube and let go of the string, or we can make the hand model disappear. But basically when you add the gameplay to it and you start shooting the arrows, you barely notice that your hand is somewhere far, but it would be terrible if you were to pull the bow and your hand is a bit too far and the string would let go automatically. The hand would drop the connection just because you have the hand too far. In VR, it really is all about the experience, so I think it is, right now it might look a bit strange, but you will see when we have implemented the arrows that it really works pretty decently. In the next video, we are going to start adding some visualization for the arrow, and later on we are going to add a real arrow that will fly from the bow and hit the target and stick to it. Again, if you want to learn a bit more about the basics of VR game development, how to use different components to create VR experience in Unity, make sure to check out my Start VR's First Steps video course, so hopefully it can give you a bit more insight in VR game development in Unity. Okay, see you in the next video.